Here, I am introducing how to define the proof stress. The diagram describes a typical trajectory of the relationship between stress and strain when applying a load on a material, and then unloading after exceeding the linear relationship in the elastic field. In this case, the slope of the line drawn as the relationship between stress and strain when the material is unloaded is said to be equivalent to the Young's modulus in the elastic range of the material. Here, said to be means that, strictly speaking, the slope is slightly different from the Young's modulus, but it can be considered to be equivalent, accepting some assumptions. You should note that here, when a load is applied to a material, strain is generated up to a certain point. And then, when the load is removed, the slope of the line, which is the relationship between stress and strain, is parallel to the line of initial elastic region in the stress-strain diagram. When unloading a material that has been deformed via A to B, it falls at the same slope as the Young's modulus in the elastic region. Then, after stress reaches at zero, certain amount of strain remains. The epsilon d shown in the stress-strain diagram is the plastic strain. The strain in the range of origin and C is the strain that remains after unloading. The strain is called plastic strain. As explained earlier, when we apply a load again, it goes up at the same slope as the Young's modulus. Then, when it gets to point B, it goes up to the right again. You should here clearly understand this movement. Suppose that a material is deformed from its origin to B via A. Then, if you remove the load from the material, it comes down to C along a line parallel to the Young's modulus. If you apply a load again, it goes up to B along a line parallel to the Young's modulus, and then it follows the curve of the original stress-strain relationship. Now, we argue about the proof stress mentioned earlier. We are considering a situation that we unloaded a material at B and it comes back to C, and then the permanent strain, which is plastic strain, is 0.2%. In general, the proof stress is defined as the stress that gives this 0.2% permanent strain. As already explained a bit, how to define the yield point is a problem, especially for materials without clear yield point. So, the proof stress is generally used as a substitute for the yield point. Basically, clear yield point does not appear except of the Miles T. The stress that gives a permanent strain of 0.2% may require repeated testing to directly determine it. This is not easy, so a tensile test is first performed up to, for example, B, and then the material is unloaded. The position of the 0.2% strain can be determined from the data obtained through the tensile test. The proof stress is obtained by drawing a line parallel to the line within original elastic range. You should draw a line originated from the point of strain 0.2% parallel to the line in the elastic region. Then, the stress at the point of intersection with the curve of the stress-strain diagram is generally defined as the proof stress. The 0.2% proof stress is determined by material testing. In some cases, the material may be pulled until it breaks. Once the material behavior in the elastic region and plastic region in the stress-strain diagram is measured, the 0.2% proof stress can be found by drawing a line parallel to the straight line in the elastic region and observing their intersection point. Remember, this is a procedure to find 0.2% proof stress. Here, you should remember that proof stress is used as a strength criterion for the material instead of the yield stress.